Next Generation Visions for Space Operations. And I'm Bill Gerstenmaier, Associate Administrator for Space Operations at NASA. In this plenary event, we are pleased to showcase future leaders in space operations, both young people early in their space careers, as well as graduate students in space-related engineering fields. This plenary is a collaboration of 3 IAF committees: the Space Operations Committee, the Space Education Committee and Outreach Committee, and the Young Professionals Program Committee. Manfred?
Yeah, good afternoon also from my side. My name is Manfred Warhaut. I'm head of mission operations at the European Space Agency. And today we have these 5 panelists which we are about to introduce to you. And they have been winning a highly competitive online contest. So they were supposed to submit 2 rounds of videos. The first video was just a pure 12-second video. And the second one was a 3-minute video where they had to address questions on space operations. And we would like that this is not only a one-way street, but that all of you participate in this plenary as our panelists are introduced. And so we would like to ask you all to think about questions you may ask later. And we will also have the possibility to give you paper and pen to write your questions down. So let's meet our speakers.
Boy in Canada, I chased the stars. That passion launched me around the globe into numerous cultures, landing me here, the European Space Agency's European Astronaut Center in Cologne, Germany, as a young professional and team member of the Columbus Systems Training Group with Astrium Space Transportation. Operations is part of a greater context. Let's take engineering design, for example. There's design, function, and material. Design being the paper calculations, the material being the material of choice. But the function is what takes the product from the paper and converts it into real life. Therefore, in the space industry, such functions are reliant on operations to transform various activities with launch vehicles, robotic rovers, as well as satellite communications and human spaceflight from paper into reality. Well, space operations is critical for any mission. However, if there was something I could put possibly atop that, it would be communication. Communication is an asset in any circumstance, may it be professional or a personal relationship, in the sense that working in a team towards a design process, training to use equipment, in any which case, communication is vital and is so much more so in the space industry. Concurrent design will result in cost savings, efficiency, and meeting of desired goals. In that case, and with that situation, it makes the most sense to take space systems and space operations and involve them in the design process concurrently. Now imagine, if this facility, the Columbus Laboratory of the European Space Agency, imagine if this facility had been designed squarely by space systems or squarely based on space operations, we would not have the facility you see here today. Therefore, it is quite critical that both these aspects are taken together at every step of the design process. I was fortunate to participate with the multinational team to develop IRIS, the educational payload, aboard Expedition 2021 conducted by Canadian astronaut Bob Thirsk. Since then, and with my tenure here at the European Astronaut Center in Cologne, Germany, it has further enlightened my experience and my passion for this industry. Therefore, I walk into this job every day with a smile on my face, and I look very much forward to expanding my career in this area of the industry.
In the next 15 to 20 years, the space program will be well on its way, with numerous countries participating in international collaboration.
Tahir works with the Columbus Systems Trainer Group at the European Space Agency's European Astronaut Center in Cologne, Germany, as a Canadian trainee with the Astrium Space Transportation Group GmbH. Tahir, you're obviously excited about your work in the ISS program. What do you see as the program after the ISS, and how is ISS today contributing to that next program?
Thank you very much, Mr. Gerstenmaier. Sorry. Well, I believe that our next giant leap in the future, the next large program that humanity should undertake, is an international human lunar exploration program. And if we have a look at how the ISS was put together, designed, and taken through to operation, we can understand what the lessons have learned and how we can go forward with what we've done so far. Now, the International Space Station is a pinnacle of human achievement. It has taken the efforts of over 16 nations over 20 years, and together we have now been able to design, implement, and operate the world's only operating microgravity platform. But the ISS did not happen overnight. It took a series of negotiations of hundreds of thousands of hours, and to put that all together, it needed some sort of an infrastructure. And if we want to get to the point where we can set up an international human exploration program on the moon, we need that infrastructure. Politically, there are frameworks that were negotiated between the international partners of the International Space Station to devise the responsibilities. Economically, we have been able to see and take the benefits from the incredible science conducted on the ISS, and then take from that and further enhance our lives. Technologically, we have taken years and years of innovation and been able to put something in orbit that we can live aboard. Taking this into consideration, and in order to put those together, we'll be able to develop a safe and sustainable program for the future to support this lunar human exploration program. And coincidentally, this preliminary framework is being developed by the International Space Exploration Committee Group, which is an extension of the Global Exploration Strategy defined in 2007. Thank you.
Thank you, Tahir.
Hello, I'm Ryan Kobrick, and I'm out at the Mars Desert Research Station in Utah. I'm here to talk about space operations, or space ops. Space ops is important to me because it looks at the big picture of how everything fits together in the space industry. All the different hardware, people, projects all come together with operations. More important than space ops is training. Here at the Mars Desert Research Station, that's a critical component of the work that's done here. With training, you can figure out all those bugs before you go to the surfaces of the moon, asteroids, or Mars. Training allows us to figure out how to conduct an operation properly before we go out and do it in the real environment. It's because of this that training essentially writes the ops manual for space operations. We learn what works best and how to do it efficiently. For space operations and space systems, it's hard to say what comes first. They can be equally weighed as they're both defined by the requirements for a certain mission, and you need both in order to be successful. It'd be exciting to have a career in space operations, as you can get hands-on experience and really work with really cool missions. Career in space ops also gives you the opportunity to help solve problems and figure out how to properly conduct things before you would go out and explore. In addition to coming out to MDRS for crew rotations, I've also spent over 4 months in the high Canadian Arctic on a 100-day Mars simulation with a crew of 7, where we conducted over 22 different science experiments, all related to Mars research. To conduct surface operations, a simulated surface suit is worn. The suit offers training in mobility and dexterity that help design protocol for science sample collection in fields like geology and biology. F-Mars habitat's located on Houghton Impact Crater, which is analogous to an impact crater that you would find on Mars, and so the research is very similar. We have 7 teams competing, and it's growing and growing every year. It's a great opportunity for university students to have hands-on experience and learn how their vehicle operates in the field and how their code and how all the systems come together. It's projects like these that really are important for developing youth's involvement in space operations. I'm Ryan Kobrick. Space.
Hi, Ryan. Hi, Ryan. So, Ryan Kobrick recently completed his PhD in aerospace engineering sciences at the University of Colorado in Boulder. And he is the newly appointed executive director of URI's Night, and just has accepted, as far as I understand, a postdoc at MIT. So, Ryan, you have a lot of operational experience from an academic point of view. So I would be keen to learn how you intend to transfer this operational knowledge from academic to real world in terms of utilization by agencies, companies, entities. So go ahead.
Thank you for the question, and of course thank you for having us on the board today. It's been a great experience working with the other 4 panelists, and thank you to the audience for attending today's plenary. So, decui, as they say here. So in academia, there's a lot of opportunities that are out there, and because of that, there's a lot of availability for students, researchers to get hands-on experience, and I mentioned that a few times in the video, so I won't harp on it too much, but those hands-on experience are great, but even more important, to transfer that into the industry, into the rest of the community, it's really important that we take the time to document the work that we're doing, get the work released in journal articles, and also along the new lines of things is social media in terms of getting videos out to the public, Twittering, Facebook, blogging, and the different avenues that are available to us, and of course talking to the press and having the professionals that write for us to do that as well. So those are all key. Just to give you an example, we conducted a food study up in the Arctic, and it was conducted by Professor Kim Benstead, who's one of my fellow crewmates and friends, who's actually here, gave a presentation yesterday on the topic. And the study was sort of impromptu. When we were up there, we realized we could add to the mission. And not only that, but we were able to publish results from that, and then it was carried forward, and now it's a funded NASA study. So that's an example of how these hands-on experience can go further and connect with the industry. Thank you.
Thank you very much, Ryan.
My name is Arya Iwasawa, studying systems engineering at Keio University, seeking to apply space-driven technologies to everyday life. Space operations is important for me because it has provided me the view from outer space, the whole globe of the Earth. It led me to the thought, by perceiving that we are human beings on Earth, we can enhance mutual understanding regardless of our background. I was brought up in 2 countries, Japan and the United States. I always had the question, who am I? When I thought of space, I came to the conclusion, why not step back and view the big picture, think of ourselves as human beings. In my point of view, space operations come first, then space systems. The reason is because I learned from figure skating, to achieve a goal, taking action is much important than just thinking with the mind. You could understand the law of centrifugal force and formulas, but you could never conduct a spin on ice by just thinking logic. What I think more important than space operations is the effective utilization of data obtained from operations. Japanese satellite GoSat, which observes greenhouse gases, is a significant example of achieving that goal. Utilization of data has the purpose to reinforce communication among countries, which would then raise the wisdom of human beings for a more sustainable, safe, and secure society. My first acquaintance with space was in science class when I was in 3rd grade. The class was about picking up your favorite planet in the solar system, pretending to be there, and sending a letter to your family. I chose the moon. I am here today because fabulous mentors have guided me to this very day. Every one of them has been my inspiration, and that is the reason why I want to inspire others. In my career, I would like to put emphasis on education. We must pass down our insight towards space to future generations to keep on pursuing the dream of human beings. I'm always amazed at the beautiful pictures of space. The mirror of a telescope reflects the exquisite beauty of space. My eyes reflect the future in which I will make my dreams come true.
Arya is obviously very passionate about space and extremely creative. She's currently a graduate student studying systems engineering at Keio University in Japan. She earned her bachelor's degree in physics, majoring in radio astronomy. Arya, you're studying systems engineering, seeking to apply space-driven technologies to everyday life. It's easy to get lost in the big machine and not keep track of where you're really going. What do you want to do as your personal contribution to this effort?
Thank you for the introduction. So far, systems engineering has taught me two things. First, systems engineering greatly differ from science in the point that it aims to achieve a certain purpose with the constraint of time and resource. Second, I learned that systems engineering is an interdisciplinary approach. In the effort, I would like to connect various things that may be constructing an interface of a system or even being a cultural bridge among countries. Before we move on to the next panelist, I would like to introduce you a short poem which was wrote more than 1,000 years ago in Japan. 雨の海に雲の波立ち月の船 星の林にこぎかくるみゆ Now I will translate it in English. In the sea of heaven, cloud waves rise, and the moonboat sails into a forest of stars. Then is seen no more. Whenever I listened to this poem, I could imagine a ship sailing across space just as a ship sailing across the ocean on Earth. I feel that someday there will become a time that space could be a habitat for human beings. I would also like to introduce the infinite wonder space provides us. In the end, I want to note that I am incredibly, tremendously blessed to be here today. Thank you.
Thank you, Arya.
Hi, my name is Brian Leathers. I'm a system safety engineer for United Space Lines, NASA's largest contractor. My job as a safety engineer is to keep the crew, the vehicle, and the employees here at the Kennedy Space Center safe. Space operations is important to me because ever since I was a little kid, I always had a love for aviation. I remember when I was a little kid, I used to run around with a fishbowl on my head pretending I was an astronaut. At the age of 14, I became a pilot. I got my pilot's license and decided to go on to engineering so that I could work in the space industry. The reason space operations is so important to me is because this is how we are exploring the final frontier. Space is the next level of exploration for mankind. Space operations has also developed some new technologies. The things that we build and design to go up into outer space has affected us here on Earth in medicine, aviation. The other thing that makes space operations important is because it is helping us expand our view of the universe. We have found and discovered and seen things now after the space industry that we would have never known before. Behind me right there is the vehicle assembly building. That is where we put the shuttle, the tank, and the solid rocket boosters together before launch. The one thing that is more important than space operations is mission assurance and safety. You cannot have a successful mission without safety. With safety, we have the safety of the crew, the personnel working here on the ground is in the process, and cannot launch effectively. The #1 goal for a successful mission is performing it safely, and the ultimate goal of space operations is to have a successful mission. Now I'm at the Orbiter Processing Facility #1 and 2. This is where we house Atlantis and Endeavour. After they land, they come here and are housed and getting prepared for their next launch. Space systems and space operations are equally important because we develop our operations off of the space systems. Without a system, we would not know the operations that we had to perform. Sometimes we have to develop a system for a certain operation. Like when we do spacewalks, we had to develop space suits in order for them to perform that operation. As you can see behind me, we have 3 pretty important things. We have the crawler transporter, which the mobile launch platform sits on. The mobile launch platform is what the space shuttle sits on before we launch it. Behind that, the tall tower, is the mobile launcher for the Constellation program. Space operations here at the Space Center has exceeded my expectations. We're achieving things that we never thought possible, moving humans further into space than before, and we are developing new technologies to go to the moon, the stars, and beyond. Space rocks. I need my space.
Hello, Brian. Brian Leathers is a graduate of Embry-Riddle Aeronautical University. He is a certified pilot and works with United Space Alliance as a systems safety engineer at Kennedy Space Center. So, Kennedy Space Center, Brian, you work in a very exciting place with a lot of activities going on, but also with a lot of history. So there seem to be many entities who would like to draw on your experience. So what can you give them in terms of operational advice, what they should do in terms of new programs?
Well, first off, I'd like to say thank you for the question, and thank you for having me here with the rest of the panelists. I've been fortunate enough to work at the Kennedy Space Center for the past couple of years on the space shuttle program. I've seen how it works, and I've seen how we operate. So to give operational advice to another company, I can take some of the things that I've seen there, and I can also throw in a couple of my own ideas. First thing about space operations that has to be done is teamwork. Space operations is a very large job. It takes many people to get the process done. I know for the space shuttle, I mean, you have thousands of people that work just to have one launch go successfully. So for future companies, they're going to need to develop a teamwork between their partners that they are going to use in order to launch whatever space operations that they're going to have. The next that goes right along with teamwork is communications. You need to be able to establish communications between these groups, whether that be over the phone, the internet, telecoms, or face-to-face. You need to have a strong communication network that's reliable. After that, you need to flatten out the company. Make sure that the information can travel from one section of the company to the other without any hold-ups, and that the employees know how to get this information across. And that needs to be for not only the company itself, but any contractors or any outside companies that they're working with. The next thing that comes pretty much in handy, and I see this out at my job all the time, is cross-training. Make sure that your employees are cross-trained, that they are familiar in many systems. In the hardware that we use at the Space Center, we have built-up backup systems. If you cross-train your employees, they become built-up backup systems. So if one employee is not there, it will not hold up a job, and somebody else can step in, and we can continue on with the operation. One thing that's pretty important is innovation. That's why I'm here and the panel's here. You need to be able to listen to new ideas, be creative, allow younger professionals to come in and give you an opinion on something. Just because you did something that way for 20 years doesn't mean it's the best way to do it. Efficiency is pretty important. You have to make sure that the company doesn't become too large. It's really easy for a space operation to get so large that you lose efficiency. You have too many people there doing the same thing, and you just need to make sure that you look at the operation first and make sure you have the proper workforce for it. Last but most important is safety. Space operation is inherently dangerous. It's a risky operation. You need to make sure that you have a safety standard put in place in the beginning and that everybody knows how to use it. You also need to make sure that this standard can change because operations change and you need to be able to change your safety practices for every operation that you have. Thank you for your time.
Thank you, Brian.
Well, obviously, first of all, because it is my job, it pays the bills. But it really is a lot more than that. It allows me to be part of the mission. In a sense, I am the connection between ground and space. I always wanted to work in the space sector, so naturally, it makes me feel I'm at the right place here in Console. Space operations gives me the opportunity to be on ground and in space at the same time. And my actions on ground actually have an effect in space. It really is the next best thing to being there. Well, first of all, the team. Space operations is nothing you can do by yourself. There are the GCs who keep the ground system up and running, your fellow operators who have done their part of the job by shift handover, and all the chain through mission control in manned systems, at least, to the spacecraft system you're operating. It all has to work together. If you start to look deeper, you cannot view space operations as something isolated anymore. It is all connected in one way or the other to the other disciplines involved, such as engineering, planning, science, and so on. Well, traditionally, space systems come first, as without a space system, there would be nothing to operate. However, ideally, space operations should come in at an earlier stage, such as the development phase of the space system. This way, operations inputs could already be introduced early on to allow the implementation of operations lessons learned, and thus lead to a better operation of the space system later on. It actually exceeded my expectations. Honestly, at first, I expected it to be kind of boring. You know, I'm an engineer by education, so I always wanted to design, develop, and build space hardware. My opinion about space operations was that the real job was already done, and that the operator just has to keep the space system up and running. That doesn't sound very exciting, does it? Well, it turns out I was wrong. After being involved in space operations now for 1.5 years, I have to say, it is everything but boring. When I go to work, I almost don't know what to expect that day. On top of that, I think space operations is one of the few space jobs that combines many aspects of a space mission. You have to know about the space hardware you're operating, of course. There might be crew activities you're involved in. You learn about the science, and in some situations you have to make decisions in real time. Being part of the chain that makes a space mission work really is inspiring every day.
Alex is an operations engineer at Space Application Services in Belgium, where he operates European payloads on the International Space Station. He holds a master's degree in aerospace engineering from the University of Applied Sciences in Aachen, Germany. Alex, you talked a lot about the importance of the team in operations, and how difficult is it to operate an integrated team when the members are on different continents and you never get to see each other?
Thank you for the introduction and the question. Well, it is not as difficult as it might sound. The key to teamwork is communications, and there are a lot of communication tools available, be it the loops, the telephone, emails, or other internet applications. However, through my experience through the Space Generation Advisory Council, as well as my current operations job, I really have to stress how important it is to meet the people you work with face to face. To be able to finally put a face to a name or voice you've been working with really adds a human component to your work, and it actually helps to improve your work even further. And I would really recommend that regular meetings would be set up between counterparts, despite any cost concerns that there might be, because I think that the benefits are far greater and value the very valuable. Thank you.
Okay. So, these young people make you really feel confident about our future in space. and I think I was really impressed by these outstanding videos. For me, and I had a chat with Bill, it was really a challenge on these 12-second spots to find out this well-gifted crowd here, who then in the second row with the 3-minute videos could be convincing to the selection committee. So let me take the opportunity to ask you to give them again a big hand for these outstanding videos. I think it is also worthwhile to mention that it's a tradition in space operations that we have redundancy, so we have also catered for the eventuality that one of them couldn't make it, and I would like to give credits to 2 additional individuals who have been selected, who have also supplied outstanding videos. On one side, this is Amanda Young of the United Space Alliance in the US, and Mikhail Kalyapin. He's a student at the Dnipropetrovsk National University in the Ukraine. So, yeah, thank you very well. Now we would like to turn the floor back to you, to the audience, to participate actively in this plenary by the questions which you would like to ask to our panelists. I would like to invite you to, where possible, also assign the designated person who should answer this question. And if you need assistance on papers, just feel free to contact the respective staff.
All right, so while you're busy writing down your questions on a piece of paper, I've got a couple here. For Tahir and Ryan, a question for both of you. Have we learned everything we need to from the ISS? To be able to do multi-year deep space missions where we're really a long way away from the planet? If not, what else do we need to learn? So Terry and Ryan, if you could answer.
Sure, I'll start off. So I think 3 of the key things that we've learned from the International Space Space Station, I knew I'd make a mistake. First of all is international symbiosis, which means we've really worked together in terms of writing requirements, cutting hardware, and making machines dock in space from multiple countries. So that's one of the big ones. Number 2, on-orbit assembly, of course. And number 3, station keeping and keeping it running for 10 years, habited. So with those key things in mind, though, now it's time for science. It's time for the ISS to be put to its initial use. And I think key to that is going to be human factors and human-related research. If your project can be run autonomously or without a human in the loop, or it doesn't require biological testing, then it can just be put on a sounding rocket. I think it's really key that we focus on the actual use of the ISS in that way. So just a random suggestion for another use of the ISS in terms of preparing for long duration missions would be to do an analog of even going to Mars by sending a crew up to the ISS for 6 months, having them stay up there, come back down to Earth, but go straight to the Arctic or Antarctic for a winter over, and then go back to the ISS for 6 months, and then come back again. And I think if we can do all that, then we'll be ready for Mars. Just want to add one quick bullet point as well in terms of looking forward to the future, is that we're entering an era of commercial astronauts. There's a group that I'm co-founded called Astronauts for Hire, and they just got recently hired for their first job, and it's going to be testing beer in zero-G, which is something that couldn't be done previously by restrictions within government contracts. So, you know, wire up the astronauts, put logos all over them. It's time for a different kind of use, but let's make sure we're using it, because it might be a while before we have something else up there as well structured as the ISS.
It was a good answer there, Ryan. I don't believe we've actually learned enough from the ISS, because we keep learning. It's perpetual, and every time you work at the frontier of an industry or a frontier of any industry, when you're pushing that envelope, expanding that bubble, you're always got to adapt, you always have to evolve, so you're always learning. And so there's, that'll never stop. So that's the first thing. The second thing is that yes, we have learned a lot from the ISS already. International collaboration with our partners is absolutely phenomenal, critical, and really was a key to getting us where we are sitting here today. But there are other things we have to consider for deep space missions that perhaps are not as prepared. that we're not as prepared for. Medically, for example, we've only been able to host crews on the International Space Station for up to 6 months. So if we want to take that further and do multi-year missions, there are certain areas of research we'll have to further before we can go there. And further, just seeing how we can use other areas of study on ground, some analogs including the Mars Houghton project on Devon Island, as well as the Mars 500 missions, which are currently going on in Russia. So those are some areas. And the last point is that the commercial industry. We have the opportunity now to embrace this in our industry, and I think this is something that's going to be very exciting and give us the strength and foresight to push forward and take that next step on a deep space mission.
So maybe then one question, and we would like you both to answer it. So the classical dilemma is human spaceflight or unmanned spaceflight. So I think, what is your opinion on this? And should we do both, or should we do either or? So what is your opinion? Maybe Aria, you can start first.
Sure. Thank you for the question. I think both are important because I consider that they both carry the dreams of people. Recently, an asteroid explorer, Hayabusa, came back to the Earth, and it brought huge, enormous excitement to the nation. Now, to answer the question, I would like to explain from aviation, taking an example from an airplane. Whenever I ride on airplanes, unfortunately to say, as a passenger, not a pilot, as Brian is sitting next to me, I feel that special feeling. Whenever you leave a particular place, you feel that certain kind of sadness or sorrow. On the opposite, when you visit a new place, you feel that excitement, overwhelming excitement, joy inside yourself. And when I was on my way to Prague the other day, I felt the same excitement and the joy, expecting to encounter new things and new people. So I tend to think that who tend to be human space advocates share that same feeling, imagining that people are really out there actually in space. There's history that missions of the supporters, I think it is every one of you here in this auditorium, and astronauts devote their lives to space. It's always good to know in life that you have worth something putting all your energy for.
Thank you, Ari. Thank you, Ari, for that. To answer the question between human spaceflight and robotic missions, I'd have to start that with, I would say most robotic supporters probably are focused on the risk to humans. There are certain things that are outside of human limits. If you're looking for long duration missions, dangerous missions, those are things that are very good for robotics. I personally am a human spaceflight supporter. The way I look at it is you have to take risk to explore. Going to Aria's, going back on something she said, aviation, the Wright brothers, go back to them. In the beginning of aviation, there were accidents. People died to prove that we could fly, that we could defy gravity. The explorers, even before that were exploring Earth, they took risk. And for us to explore our universe, we'll have to take risk. The reason I say this is because a computer cannot operate like the human brain. Regardless of the technological advances that we're making, we still don't have a computer that can do what the human brain can. The other thing is, if a computer loses communication with its operator, there's no way to control it. At least a human can make those decisions. In emergency situations, that definitely comes into play. Will the computer make the right choice? To have that human element, the human control is something that definitely needs to be there. The way I look at it is that a computer doesn't have the 5 senses that a human does. So when we do send somebody out into outer space, they can describe it to another human the way I would describe it to you. You could understand coming from another person. Just as another example from aviation, autopilot, it's great. It's an amazing technological advance in aviation, but not many people are willing to jump into an airplane right now with just autopilot and not a human pilot there for a backup. And that is how I kind of view human spaceflight and robotics, is that we do still need that human element in space travel. Thank you.
Thank you. Alex, some advocate autonomy for the crews in human spaceflight. You know, the counter-argument is that real-time control procedures provide safety and improve productivity. You know, as the distance increases, as we go to Mars and other places, will that dictate a different approach? And what is your view about how autonomous the crews should be and how much structured and interactive they ought to be with the ground?
Well, the current way it is done on the ISS is that ground is always there to support the crew if needed. So that is certainly an advantage in LEO. Of course, once we move on to Mars and the time delay kicks in, then we definitely need more autonomy, as ground will not be able to help immediately. So the crew definitely needs to be able to handle any emergency situations by themselves in a certain amount of time. Let's say if there's some situation that is not really very urgent, it can still help to contact ground and get further support for that. But within a certain amount of time, and travel to Mars, in worst case that would be 40 minutes, crew definitely needs to be able to take care of themselves, perhaps with the aid of automated systems on the station, but it depends to be seen how that would be implemented in detail.
So I have here the first question from the audience, Justin Park, United States, to all of you, and if it's possible, maybe we make a quick poll. Question as follows: as part of this space generation, what year do you think you will personally go into space, and why? Short and crisp. Go ahead.
Well, I have a quick answer for that and a good or an explanation. I would think, I don't know, maybe 2035, 2040 or something, because then I'm old enough and put enough money to the side to being actually able to afford a flight. Even though they're cheaper then, most likely. But I think it will just take a few years until all the opportunities become available. And one thing I'd like to add, I want to go orbital and not just suborbital. So.
I guess I can answer that too. I'd like to preface it as I'll go as soon as they'll send me. So if anybody wants to give me the offer, I'll go immediately. But I agree with you. I think it'll probably, I would say, a minimum 10 years so that we can figure out the path that human spaceflight is going into. And once they figure that out, I think it'll be a little easier to determine. And I think the commercial entities will also have their feet a little bit more off the ground at that point.
So I'm a first year in graduate school, and for being an astronaut, I think you have to have 3 years of experience in the science fields. And well, I'm in my first year, so there's 2 left. And I think I've got to go training, so maybe 20 years later.
So I'm in the same boat as Brian. I'm ready to go, but it depends on the vehicle. So that's a key part of it. And you know, realistically, I think 10 to 15 years is more the time frame that flights will really be available to the public. But if anyone who knows me might know my academic background, that I've got a few student loans to pay off first.
Yeah, I'm going to go actually with Alex on this one. That's about 2035, 2040. Again, it also depends on who you fly with, and I definitely fly with any of you guys any day. So.
Great. We got some questions here for Arya and Ryan from the audience. do you feel we take sufficient risk to make exploration meaningful? So maybe we'll start with Ryan. So do we take enough risk to actually make the adventure or the exploration meaningful? Or do we take too much risk?
Well, in terms of what we've designed, we're designed to take the risks that have been already planned out in terms of the current structure of the agencies. That doesn't mean that going forward we can't change how we approach everything. I think that it's important to understand what the variables are around you before you just jump into anything. So I think it's pretty well assessed and it's been developed, but there's a lot of risk that's taken in terms of redundancy on the ground or operations or any of those fields that you can cut away segments and really streamline the process. So I don't want to say too much because I don't want to step on too many toes. So I think there's definitely ways out there of reducing risk that I'd be happy to talk to about after.
So what I've learned from radio astronomy in my undergraduate program was that to imagine beyond the visible things and to expand the imagination to the invisible was what I've learned from radio astronomy. And learning systems engineering, I learned such tools like failure modes analysis. And imagination, taking imagination is always, I think, it is the key to reduce risk in space activities.
Okay. Let's go on. So we have still questions floating in. Here is a question from Jay Bartow, a retired NASA employee, addressed to Brian or Alex. Maybe we start with Alex. When did you start your job? No, sorry. When you started your job, were you provided all information you needed to learn, or did you have to learn by word of mouth?
Well, comparing to the team I work with, I was one of the few people who actually had a full space background. As mentioned earlier, I did aerospace engineering, so I knew what I got myself into. While other people of my team, they came from different backgrounds. So, and they told me they had to struggle a lot with acronyms and things like that, and they needed to learn more about space than I did. On the other hand, for the job, I think the training we got was really good, and what really helped was the on-the-job training. It doesn't matter how much you read, what you're supposed to do, it matters that you do what you do, and that's how you learn best.
I'll actually have to agree with Alex there. I had a background in aviation, aerospace engineering, and aeronautical science, and I've been flying. So when I got there, I did have a lot of background information, and they do supply you with a lot of technical documents. You were talking about acronyms. I think we have a 1,250-page book of acronyms, and that's all available online too, which thank goodness I didn't have to print it out. But on-the-job training was the most important. Getting out there with the hardware, experiencing the hardware, it's something you can't learn out of a book or off of a blueprint or a schematic. So I would definitely say the on-the-job training and the word of mouth, the experience from my coworkers who have been there much longer and are a vast amount of knowledge, pretty much is how I learned to do what I do.
Okay, another question from the audience from Kim Binstead of University of Hawaii. And this is, I guess, for Ryan or anyone else who would like to answer. How would you train on Earth for a manned expedition to an asteroid?
Well, that's an interesting question. So the key to a lot of these environments and analogs is this echoing funny? Is to really match the environment that you're training in with where you're going. So an asteroid being another airless body, some of the key properties there might be the mechanical properties and like dust abrasion, which is what my PhD was on. And so in order to study something that matches that, you would probably go to a location like a Hawaiian volcano or, well, not just, you know, any volcano has properties with materials that are already naturally in the environment. So that would be one thing. If you're worried about the duration that the crew is away from home, then you isolate them. You put them in the Arctic, or you put them in something like Mars 500, and you separate them from everything else. So you do need to try to incorporate as many of those variables as possible, which is why the Arctic was so good for Mars training. But I think there's a lot of good options out there, and Hawaii is probably our easiest one coming from the U.S. because it's isolated and it's got a rough environment.
Okay, I have here a question maybe for Tahir. Robin Rouse, Surrey Space Centre from the UK. Question as follows, from an operations point of view, what kind of disadvantage or advantage do you see considering increased spacecraft autonomy?
Okay, thanks for that question. I believe it has to be an appropriate combination of the two. There is no stopping the fact that everything in our world today is tending towards that fact. And in the space industry, we do have modes and procedures and ways to ensure things operate the appropriate way and make sure things do not get out of hand. But you always need that human factor and that human element, both if you're operating a spacecraft from the ground, as well as if you're sending it off on a deep space mission. And it's something that Brian mentioned earlier in some of his speeches. And I think that this is something that should be taken carefully, not necessarily rushed into, to rush into full autonomy, but ensure that there is always someone watching what's going on and making sure that when you are operating it, that you do so with ease and not necessarily make it too complicated that you can't get any particular science or function done.
Thank you. Brian, when did you decide on a career in space operations and why?
Thank you for that question. Actually, there was a tidbit of it in my video. When I was younger, I always dreamt of being an astronaut. And if I would have asked my mom before I got here, there are pictures floating around of me with like aluminum foil wrapped all over my body and a bowl on my head, and I thought I was a moon man. So ever since I was a little kid, I always had a love for space, for aviation. I was lucky enough that I got to start flying at 14. I got my pilot's license at 16. So aviation has always been a huge part of my life. So I would say pretty much as far back as I can remember is what got me started in aviation and aerospace. And ever since then, I've just kept going in that direction, and I don't really hope to stop anytime soon. Thank you.
Would any other ones, if you guys want to answer that? Why you chose space operations?
Actually, the one book that really guided me into this area of the industry was Gene Kranz's Failure is Not an Option. And that is a very popular book, I know, among some of the panelists and some of the people I've had a chance to speak to over the past week. And it is definitely detailed enough for you to really understand the risks, but also the rewards of working in this area of the industry. And that's the reason why I actually took the opportunity to work at the European Astronaut Center, see it firsthand, and had the opportunity here to present in front of you today.
I'd say the opportunity that came up when I was, the first time I went to the desert was during my master's, so it was at Penn State after ISU. I had already heard about it. So just seeing people out in the field and getting some hands-on experience was like, oh, I want to do that. So that was a really good way to get involved. And then just over the years, that kind of kept building up until we got the opportunity to do the really big mission in the Arctic. So that was great. And I'm just curious if the young professionals and the students in the audience would just stand up real quick just to show everyone else who you are, because you'll be sitting up here next year, hopefully, as well. Go ahead. There you go. I think there's 33% of the conference is young professionals and students. So take a look around if you're sitting, hire these people. And for the students that are just getting involved, try to pick 2 or 3 opportunities. Try not to do too much. Someone important to me once said, multitasking makes you stupid. So really focus on those things, like your education, of course, and then SEDS or whatever. But think of your energy as like a beam of light, and if you scatter it in too many directions, you're not going to illuminate anything.
Thank you. Maybe, okay, go ahead, Aria.
I thought space was my calling was when I was in 6th grade. Ever since that, I took that science class, which was introduced in the video when I was in 3rd grade. I had the question, how do people observe space? That question led me to the Subaru telescope, the telescope at that time which had the largest mirror among the visible light telescopes. My family visited the summit of Mount Mauna Kea on Big Island of Hawaii and visited Onizuka Center, the building which was built in memorial of Ellison Onizuka astronaut. Whenever I closed my eyes, I could still recall the scenery. There was a big Milky Way floating across my skies, and because of the blinking stars, the sky bellowed like a curtain, like it was caressed by a soft wind. That was the time when I decided a career in space, not dreaming to be an astronaut, but an astronomer who observes from space. And I don't know what you call that as an occupation. Space has been and forever will be the thing which would ignite my heart on. Thank you.